right, today we're going to take a look at the activity writing stories from graphs. So the directions, you'll be analyzing a graph, then writing a story that matches the details you find in the graph. Some of the details you will look at are points on the graph, intervals on the domain during which the function follows different rules, and average rates of change for those intervals. Points. First, identify at least 6 points from the graph. Be sure to include the starting, the ending, and any points where the graph makes a significant change. You may want to organize these points in groups based on the part of the graph they come from. So the graph we're talking about, we're going to go with the first one. I'm going to shrink this so you can see. I gave you 2 graphs, but we're going to talk about this first one on page 21. So as a group, come up with 6 points from that graph. Okay, so this is the one, again, page 21. I'm going to make it bigger so I can go back to the other page. Again, come up with 6 points, at least 6 points. You can identify more. And then answer question number 2. Do you have any initial observations about these points? What patterns can you see? So I'm going to pause for a few minutes while you and your group work together to identify at least 6 points in that graph on page 21. All right, let's take a look at some of the points you listed and talk about what you have in your initial observations. So, Valentine, what's one point that you and your group came up with for the graph? 0, 10,000. All right. Andrew, what's a point you and your group came up with? 8,510. Abby, what's a point you and your group came up with? 24,000. All right, Jordan, what's a point you and your group came up with? 2,000 and what? But the 60 goes first, right? It's 60 comma 2,000. All right, Sion, what's a point you came up with?
A point I came up with 43,000.
43,000. All right, Amaret, what's a point you and your group came up with? 90 and 500. Maggie, what's a point you guys came up with? 50 and 2,500. Adrian, what's a point you guys came up with?
2,530.
What always gets listed first? The x coordinate always has to be listed first. So your x coordinates only go from 0 to 100. So 30, then the 3,500. Annabelle, what's the point you guys came up with? 100, 0. Isis, what's the point you came up with? Which makes me realize the second point I was given, this should be 10, 8,500. Sorry. Do you have any points that we haven't listed already yet, Isis? Elijah, what about you? Any points we haven't listed? And Beatrice, what about you? All right, so if we take these points, I'm going to mark these points on the graph to see what you guys have marked. Again, I'm going to have to shrink my graph down so it'll fit on one page here. And I know it's going to be, mine's going to be sideways. Sorry, I forgot to flip it before I put it in the book. So the first we have 0, 10,000. That's our start. Then I have 10, 8,500. I have 24,000. 62,000. 43,000. 9,500. 52,500. 33,500. And 100, 0. And that is my end. And we were told to list the starting and the ending and any points where you felt the graph made a significant change. So where would you say is the significant, where does this graph make its biggest change? Where on the x-axis does this graph make its biggest change? If we look here at 20, we seem to change functions here. So we have one function from 0 to 20, and then we have another function that goes from 20 to 100. What type of function do you think goes from 0 to 20 just based on shape and behavior? What type of function do you think that would go in that first, that based on the shape and the behavior of it, what type of function do you think we have there? Yeah, I would say this is a quadratic that is decreasing. And then from 20 to the end, what type of function do we think we have there? Or do we know we have there? What type? It's linear with a negative slope, or decreasing. So we definitely have two types of functions going on there. We can see the different types of behavior. In the linear, it's very easy to see the slope. If we go between any 2 points here I go down 500. And I go across 10. So my slope for my linear function will be negative 500 over 10, which would reduce down to negative 50 over 1. So I can find the slope of that part. The quadratic part is a little tougher. We don't have a lot of exact points to go from. We know we have 0, 10,000, 10, 8,500, and 24,000. So we can see, I mean, just if we take those 3 points, that's not a great but if I have 0, 10,000, 10, 8,500, and 24,000, I know from 10,000 to 8,500 is minus 2,500. From 8,500 to 4,000 is what, minus 3,500? No, 40, minus 4,500. I don't have it. It's hard to see because I mean, we would normally look at the second difference, but we only have one difference that comes up after that, so it's hard to see, because from 25,000, or excuse me, 2,500 to 4,500 would be a minus 2,000 if we were to look at the second difference. But we would need more points there, but we can kind of see a pattern. But we would need a few more points in there. Again, we're only seeing a very small portion of that. So in that second part, the things I've been talking about here, that's what should be in that question number 2 for you. What observations are you making about these points? These are the types of things that should be talked about. I'm not going to write them out for you. I've talked about them here, but I'm not going to write them out necessarily as the answer on number 2, but these are the types of things. When did it change? What do you notice in the first set of points? You should have looked at, if you're saying it's linear, been able to talk about a slope. So we know from 20 to 100 on our x-axis, we have a constant function. We don't have a constant function from 0 to 20. So I'm going to go back to that page now. I'm going to make it bigger here and go back to that page. So you should have hopefully taken some of that information and used it to answer question number 2 there. Intervals. Identify the intervals of the domain that make up the different parts of the graph. Read the box to the right about how to write number intervals. So there's 2 ways. It says, let's say we want to identify from 0 up to 5 of the input or x values and include both ends 0 and 5. We could write 0 is less than or equal to x is less than or equal to 5. So this is what we call inequality notation. Or x is in, and you notice I use bracket 0, comma, bracket 5. This is called interval notation. In interval notation, which was introduced last year to you, I know it's been a little bit of time. In interval notation, we use a parenthesis for less than or greater than, and we use a bracket for less than equal to greater than equal to. So if we have the less than symbol or the greater than symbol, then we use parentheses. If it's less than or equal to, greater than or equal to, we use brackets. And brackets mean that the numbers are included in the interval. Parentheses mean that they are not included in the interval. And when you have something like in the middle of our graph where you change functions, you can't have that number included in both the quadratic and the linear function. It has to be included one side or the other. So you have to make that decision. So what are the intervals that make up the different parts of your graph? Well, you told me that the change happened at 20. So from 0 to 20, we have one function. You told me that was my quadratic function that was decreasing. So we could write that as, and I'll write it in both notations. We can say 0 is less than or equal to x is less than or equal to 20. That's our inequality notation. If we were to write that same thing in interval notation, we would write bracket 0, 20 bracket. Now, because we included the 20 in the first interval, we can't include the 20 in the second. So when I talk about the linear function, then I have to say 20 is less than x is less than or equal to 100, because our graph went to 100. Again, these intervals are all about the sections of the x-axis that we're talking about. So in this case, if we go to interval notation, the 20 is just a less than, so we would have to do parenthesis 20, 100 bracket. That's how we would write them in interval notation. Then 4 says, what observations can you make about the function on these intervals? So I want you to go back to some of the marks we just made on the graph, and I'm going to give you a minute to write your observations about these intervals. So what are the observations about those intervals we just talked about? We actually marked it on the graph. What is the significance of the interval from 0 to 20? What is that interval? What does that represent on the graph? What did we say 0 to 20 represented? I have it written right on the graph. We talked about it. What does 0 to 20 represent? Quadratic decreasing. This is your 0 to 20 right here. That's that interval. When we talk about intervals, we're talking about that chunk of the x-axis. When we talk about the 20 to 100, what are we talking about? What does that represent in our function? Represents the linear function. So your answer to number 4 should have talked about those two things. The first one deals with our quadratic decreasing. The second one deals with our linear decreasing. Those are the two sections of the graph we'd already talked about. Those intervals are talking about sections of the x-axis. It's breaking up your x-axis. So it's talking 0 to 20 is talking about the quadratic function that's decreasing, and 20 to 100 is talking about the linear function that is decreasing. All right, the next page, average rate of change. It says identify the average rate of change for different parts of the graph. Read the box to the right about how to find the average rate of change. The average rate of change is similar to the idea of slope, but can be used for nonlinear functions too. It involves finding how much the function changed over an interval divided by the size of the interval. For example, if f of 5 equals 80 and f of 9 equals 60, then we know that the function went down 20 on the interval 5, 9. This interval is 4 wide, therefore the average rate of change is that negative 20 divided by 4, which equals 5. So, for the linear part, the average rate of change is easy. It's linear, so we have a slope. For that first part, so when we're talking about that interval from 0 to 20, we said that was our quadratic and that it was decreasing. So we know we found some points there. We know our quadratic at 0, we were at 0, 10,000. At 20, we were at 4,000. So the top of our average rate of change, and I'm just going to use the abbreviation ARC for average rate of change. Write it up there so you remember what ARC. We went 10,000 minus 4,000 over 0 minus 20, because our x, we started from 0 and we went to 20. Well, 10,000 minus 4,000 is 6,000. 0 minus 20 is negative 20. Anytime they both end in zeros, I can take a 0 off of both of them. So my average rate of change is now down to 600 over negative 2. Which can be taken down to negative 300 over 1. Now, we know a quadratic function does not drop at a regular interval, but the average rate of change of that quadratic function, it's dropping 300 for every one it moves across. On average. Again, we know that it's not linear, so it doesn't necessarily happen like that exactly. For the 20 to 100, which was our linear decreasing, now this one we actually already did find our average rate of change. We could pick any 2 points on there. We could even go from the 24,000 to the 0, 100 and come up with that. But we chose 2 points. I used 43,000 when I marked it on the graph and 52,500. So my average rate of change is 3,000 minus 2,500 over 40 minus 50, which gets me 500 over negative 10. And again, I can cross out a set of zeros there. So my average rate of change for the linear is negative 50 over 1. So again, it's not saying it's necessarily a slope, though, in the second part, because it's linear, that negative 50 over 1 does represent slope. But the negative 300 over 1 is not a slope. It is just an average rate of change. So now we've done all the math that goes with the graph. Now is what you guys get to do. You get to write a story to match the graph. Now that you have identified some points on your graphs, intervals that name the different parts, and the average rate of change for each interval, it is time to write a story that matches. Be sure to include all of the following: a real-life situation from which the function data comes, identify what the input and output quantities are and what units they are measured in, and separate descriptions for each part of the graph. So you notice right now we have numbers labeled on our X and Y axis, but we don't have labels as to what units they are. Is the X axis in time? Is it in distance? And what kind of times? You're saying, is it time? Is it in seconds? Is it in minutes? Is it in hours? The Y axis, is that inches, feet, yards, miles? That has to come from your story. You have to incorporate that, something that makes sense based on the function that is happening. And obviously you need a description that describes the quadratic part of it, and then you need a description for the linear part of it. And if you finish the story, there's a challenge that says write a piecewise function that matches the graph. Be sure to include the intervals for the parts. All right, that's a challenge part to it. So I'm going to give you time now in your groups to write your story that matches your graph.